friction and energy. Let the lesson begin. So now today we're going to be learning about what exactly friction is, what exactly energy is, and some real-world examples of these concepts, and applying these concepts to our CO2 dragsters. So let's start with number 1. What exactly is friction? Friction is a force that resists motion, and it tries to stop two surfaces from slipping or sliding against one another, as you can see in this diagram. Friction comes in two forms, either static friction or kinetic friction. Static friction is what stops an object from sliding down a slope, as you can see over here, and kinetic friction is a force that stops moving objects, and it slows them down to a stop. Kinetic friction is the friction that we'll be applying to our dragsters. Now, you don't want much friction in your CO2 dragsters, because that would be quite the drag. So, what exactly is energy? In physics, energy is defined as the capacity to do work. Energy can appear in many forms, which apply to our CO2 dragsters, and we'll discuss them on later slides. The first law of thermodynamics is that energy cannot be created or destroyed, which will also apply later, and it only changes from one form to another. Proper usage of our energy in our CO2 dragster is what will make our dragster go fast, while misuse will result in slow speeds. So now some types of energy that apply to our CO2 dragster are potential energy, which is stored inside of the CO2 canister, kinetic energy, that is when the CO2 canister is opened and the air is let out, gravitational energy, which is the weight of our dragster, sound energy, which is energy released when the canister is open, and thermal energy, which is some heat created when the air is released. So, over here we have some terms, and on the other page in the notebook we have some definitions. So let's match these together. Potential energy is defined as energy that can be used at a later time. It is stored in objects due to its position or other factors, so C will be potential energy. Now, thermal and sound energy are both energies that we do not want to really use in our dragster, because they're more of a waste of our energy, because all we want is our dragster to go fast. And so, A would apply to this example. And lastly, gravity is, of course, a force that pulls all things towards the center of the Earth, so B applies to this. Number 3, application in the real world. So, as you can see in this dragster here, the amount of surface area that friction can be applied to has been minimized. As you can see, its frontal surface area has also been minimized, and it has this needle-like shape. The amount of energy that can be used is maximized, as you can see, of course, with the huge amount of flames coming out of the back, and it has been used as efficiently as possible. So let's talk about some quote-unquote features of this car. The missing tire here is creating, of course, a lot of friction, which will inevitably slow the car down. And a lot of energy is also being wasted by the wheels because of this, which is obviously why we have tires on our cars. So, practical uses of this information. For friction, as little surface area as possible should touch the air and the ground. And for energy, energy should be used as efficiently as possible, since we can't maximize our energy since we're limited to only one canister of CO2. Number 4, application of these concepts on our dragsters. So, as you can see here, friction will try to restrict your movement. Friction can form in or on the frontal surface area of the CO2 dragster, like this area over here, anything that will touch the air when it's going forward. It can also apply on the bottom of the car if there's any debris that can fly up. It can also apply on the wheel axles, which is really important, which is why you have to cut your wheel axle holes properly. Otherwise, the axles could result in a lot of friction inside of the hole, and it could slow down your car a lot. And lastly, rough surfaces on the wood of the car, such as if there were bumps on this car, then that would also result in a lot of friction created, and it would slow down the car. So energy. as you can see here, there is pressurized CO2 inside of our CO2 canister, which when the cap is released here, will the force will be exerted, which will push the car forward. And the car's mass, which is inertia, will try to stop that movement, which is why we want to have the least mass as possible. And as I'm sure you can tell by now, there is a relation between force and between friction and energy. So the more energy that you apply on an object, the more friction will try to resist. In conclusion, our three main concepts were what friction is, what energy is, and how we can apply these concepts to our CO2 dragster. Here is the bibliography, and thank you so much for listening.